Hello, and today we're going to be learning about inverse trig functions. Okay, so first of all, let's take a look at some of these graphs and their domains and regions. Now, if you look here, you can find all of the inverse trig functions that we are going to be focusing on, and their graphs and their domains and ranges. And the reason why some of these are it looks like it's cut off almost, is because without that specific domain, then it wouldn't be a function, and that would be a problem. And we learned a lot about this in pre-calc, but this can also be written as sine to the negative 1, or it's not even said sine to the negative 1, but it looks like it, of this value. And the way that you evaluate this is just kind of like a review, is that you find where in the unit circle for the trig function sine that equals 1 over 2. So in this case, that would be pi over 6 if my pen decides to work. Now, the important calculus part about this is finding the derivative of all these inverse trig functions, which can be found here. These are all the little equations, I guess you could say, that let you know how to find the derivative of each inverse trig function. Next, we're going to be looking at some examples. Okay, so for example, you have this right here, and you're trying to take the integral. Then you look here, and then you kind of like match it up to any one of these equations or formulas that you can kind of see a resemblance to. So right now I see a resemblance with secant, so I'm just gonna try and find the u value, because that's really what makes the arc secant u. Okay, so here we have the u here would be in this position. So if u squared equals 4x squared, then we can say that u equals 2x. Make sense? And so in this way, the integral of this right here is the arc secant of 2x plus c. So, and then whenever you're just solving problems like these, the integrals of these kind of weird things, you can kind of see the resemblance in whatever formula or equation you see. So for this one, you would see a resemblance in arctan, which I wrote out here with my dying pen. And actually, for this one as well, this is going to be arctan. And then you can start solving from there after, like plugging in, kind of using some algebra. Yeah.